Okay. So I guess the first question the audience might be interested would be like, what inspired you to build an open data science platform as KNIME? So we all know KNIME is a very powerful visualization tool in the data science field. So what kind of inspired you, but at the very beginning there, to build up KNIME?
But the reason we started building KNIME was that we needed almost like an experimental workbench for some of the algorithms and a lot of the methods that we were developing in my research group at the University of Constance. So it's always clear that, I mean, you have two choices when you do research, right? You can develop new algorithms, new methods, and then you show on some benchmarks that they work great. And that's it. You publish a paper and done, and people will have a really hard time using those kind of new innovations. Or you, at the same time, also publish a library. But even a library is usually not usable standalone, and especially in a data science context, you need something that does all of the environment needs to ingest the data, produce the visualizations, orchestrate all of the other tools around it, so that your single algorithm that you want to talk about, that you want to publish, can actually be used in real life. That's why we started it. The reason it's open source is obvious, right? I mean, we wanted to make it usable by everybody, and we also wanted others to contribute their algorithms to the tool. We wanted to be able to reach out to a lot of the other open source libraries, nowadays Keras, but back in the old days was, of course, also Weka, XGBoost, and some of those, be able to reach out to those and make use of them instead of having to reinvent the wheel.
Yeah, sounds really cool that you have this great idea bandwidth was back then to kind of providing great benefits to all the data science field here to replicate all the work so easily. Yeah.
Exactly.
And what actually like how do you decide to specialize in this workflow here?
From a computer science point of view, and I'm a computer scientist by training, to me, visual workflows are just another way of putting together a program, right? You're visually programming. And for things that you do with data, you're not actually creating typical program logic, but what you're programming is, in a sense, it's data flow logic. And data flow is very easy and very natural to represent in a visual metaphor, right? So instead of having to code that as text and say this connects to this and the data flows from here, you put that together very visually, and that's why we decided to use a visual environment to do that. And one of the big differentiators to a lot of other tools that now also have this kind of visual workflow frontend is that from day one, we knew that's also the underlying architecture. So what you build in KNIME visually, these components the nodes that you connect to each other, underneath the hood, it does run a sequence of modules that are being called. The other huge advantage is, of course, you can reach out to other technologies that may be written not in your favorite coding language, your favorite programming language, because it's all encapsulated in the same visual node metaphor, right? So underneath the hood, we are reaching sometimes out to chemical libraries that are written in C. We are reaching out to things that are written in R. We are reaching out to things that are written in Java or JavaScript for some of the visualizations, or we're reaching out to things that are written in Python and other languages.
Yeah, that's so cool. Yeah. Okay. As the CEO of KNIME, are there any developments in KNIME that have like surprised you or changed your approach to the data science in general? Like since it is developed.
I'd answer that just as a data scientist that has been in the field for 20 years, and back then it wasn't called data science. There were a few things that surprised me, but they don't surprise me that much anymore. When big data first came, right, everybody thinking, oh, this is going to be the solution to everybody's problems, and it's all big data. And I kind of expected that not to be the ultimate solution for all problems and then some. And what kind of surprised me is this hype around neural networks, that now deep learning, right, which I saw 20 years ago when I first was doing research. I was working with speech recognition and using neural networks for that one. And it's kind of funny to see that we obviously didn't learn anything from 25 years ago, where that hype also cooled down, and we could just see the same trend now with deep learning. So to me, it's more certain types of methods that are popping up where you're thinking, oh, this is really interesting. This is a very nice idea of doing this. When support vector machines first showed up, kernel machines, that was a very, very interesting development. So it's more individual little method developments. But the general trend I think it's pretty obvious where this is going, and it was obvious for 10 years, right? We have tons of data. It's going to be more and more data. We need to do something with this. There's a lot of value in there. So I think that didn't surprise me that much. But if you were to ask me what kind of new methods pop up in 3, 4, 5 years, I don't really know. We'll see. Going to be fun.
And they're like also, on the other hand, there are so many new and popular programming languages right now. So yeah, like Go personally is a very pretty new. I also have some interest into learning it. So do you have also any plans of incorporating any of those new languages in KNIME?
So we incorporate, so KNIME abstracts tries to stay above these languages and kind of abstract away from them. We have been doing that from the beginning with R. Then we added a Python integration. We don't have JavaScript integrations.
Yep.
We do interface on the execution engine technology. We are, of course, also wrapping around Spark. We have connectors to Databricks, Snowflake environments, and Go for container management is something that's part of the KNIME server, right? When it comes more to the execution engines, we are relying on these technologies as well. We try to stay away from betting everything on one particular technology, but stay, in a sense, technology agnostic, so that at the end of the day, if you connect to your Azure or to your AWS environment, it doesn't really matter. The workflow looks the same, just the connector at the beginning looks a bit different.
Yeah, that makes sense. Yeah. Did you receive the email that we sent you about the workflow guidebook co-authored by KNIME and RMDS Lab?
Yeah, I saw that. That was a nice collaborative project. I think this kind of material, these educational materials around how to very quickly get started with KNIME are extremely valuable. So it's nice to see the output of that project.
Yeah, this is pretty cool about the first cooperative between the KNIME and RMDS there. Finalized product. In a study of big data projects, Gartner reported that 60% of the big data projects are run by companies that are unsuccessful. How do you think the success ratio can be improved? And do you think like the combination of the professional data science communities and platform like KNIME can help?
I think so, absolutely. And I'm pretty sure the 60% is a very optimistic estimate. It's probably even worse. One of the biggest problems that we also see when we talk to customers is there's a lot of data science activities going on in companies, but there's no clear path on how to really put that into production. Right. So, I mean, or put differently, a lot of data science research, experimental exploration, right? What kind of methods could work and help us for a particular application? For instance, are coded in a Jupyter notebook. I've never seen a Jupyter notebook run in production. Right. So that's taking the insights that you're generating there, the models that you're generating there. And it's not just the models, it's also the data pre-processing. That's massive part of a successful data science project. You need to have an integrated way of putting all of that, moving that very easily into production in a controlled manner. And I think that's exactly where environments like KNIME can help, because we already control very closely what's being executed underneath the hood. And we have mechanisms in place that allow you to automatically grab the part that needs to move into production and move that automatically in production. So it's almost like you need a CI/CD, this continuous integration, continuous deployment concepts from software engineering. They also need to be kind of moved over to the data science environment. Right. So often when people talk about end-to-end data science, they stop with and there's the model. But that's just where it gets really interesting, right? How do I move this model into production? How do I monitor constantly that the model is still performing up to my expectations? How do I retrain when that doesn't happen anymore? How do I automatically replace that, validate that the model is still doing fine on past data? Those types of things need to be made it very, very easy for the data science team.
Yep, that's really good. A very good point there about the execution of the data science projects. And the platform like KNIME would definitely help in the reproduction process. And a data science community would also be helpful in this process as well.
Yeah,
moving the whole process. Yeah, and so right now we have been talking a lot about your past history there. For right now, what projects are you working on right now?
There's a lot of stuff going on. I mean, and one of the, for once we are going to replace all of the visualization routines in KNIME. We have a lot of different libraries that we've integrated over the years. We're going to base that now all in Apache eCharts. Super cool, very powerful library. We're also working on a way for Python developers to add node extensions to KNIME without having to touch Java. Right now, you still need a very thin Java wrapper around it, so you can directly submit Python extensions to be used from within KNIME. And then the CI/CD stuff, we have a blueprint for that already running on the server that automatically allows you to share workflows, have them automatically validated, have them automatically moved to into the production server, monitor the automatic retraining, and flag your users when they need to do something. And then, of course, moving all of this to the cloud, we're working on a cloud-based, on a browser-based version of the KNIME Analytics platform as well, so you can edit the workflows in the browser.
Yeah, sounds like pretty cool stuff. You're adding a lot of new functions, extensions to the KNIME platform, and we're definitely sure that KNIME will be more and more easy for the users to use and have really more functions for the users to take advantage of the projects there. Okay, so as a CEO of KNIME, what KNIME products would you recommend to someone just get familiarizing themselves within the platform, a completely new beginner?
So we have what we call on our website, what we call the Learning Hub. That's probably a good starting point. There's a couple of books in KNIME Press. Actually, the book that we did together is probably a good resource to get started. We have e-learning courses that are free to use. We have, and I probably also, the moment you start building workflows, browsing around in the forum, lots of interesting discussions there, but also browsing around on hub.knime.com, our workflow hub, where you can find lots of blueprints, over 4,000 workflows by now, that show you very basic things. How do I define a decision tree, to very complex applications? How do I build a Twitter analytics workflow? How do I do churn prediction? So I think that's learning by looking at examples and then starting to build it yourself is probably a good way to do it.
Yep, it sounds pretty cool. Yeah, I also took two of the online classes from KNIME. I learned the KNIME from those courses with they're like 15 or 16 single assignments for us to kind of practice on KNIME. Yeah, those are pretty helpful when for someone that is completely new to KNIME to get familiar with the platform there. Yeah, pretty great.
Good, awesome.
Yeah. So, what resources would you also recommend for those interested in learning more about those trends about the data science field and the KNIME project?
I think our blog is probably a good way of getting, we try to publish blog posts around new technology developments that we're adding to KNIME, but we also have blog posts where we are commenting on recent developments in the data science space. And then just generally, there's, I think, a lot of very cool online resources where you have people, thought leaders in the data science space talk about it. I don't really think there are very solid books around what data science does and the methods, but if you're interested more in being kept up to date with current trends, then I think there's no way around online resources. Sign up for our blog. I think that's a good starting point, but our blog is not the single source of truth. There's tons more stuff out there worth exploring.
Yeah, cool. Thank you for the recommendation. I'm sure that starting point is also very good for the beginners in this field here. So yeah, let's talk about a little bit future stuff. So what trends would you foresee in the use of application of big data? In the future?
Oh, wow. How do they always say predicting is really hard, especially when it comes to the future. I think it's hard to say what's really going to happen because we tend to overestimate the impact. But I really think all organizations will move doing something with their data, analyzing with their data, benefiting from insights generated from their data, will move that to the center of their organization, right? I foresee almost every organization will have some sort of a chief data officer that's really put in charge to make sure that all of the data that's gathered in your organization is put together and regularly analyzed to identify trends before they bite you, right? That's really what it's all about, because your competition will be faster anyway. And that goes way beyond. So, but I think a lot of smart companies will become a lot smarter about how to contact potential customers, how to talk to their audiences, because they will actually understand before the outreach what people are interested in. So if you keep getting emails of the type, hey, are you interested in, I mean, you get those probably as well, right? Hundreds of stupid emails from people that they haven't done any research on your organization, on you, they know nothing, right? They just send thousands of emails a day. I think that will disappear and will be replaced with much more targeted, much better personalized outreach where they really know a lot about you, simply because the information is out there, right? You just need to mine it to derive the insights. And people will increasingly just expect that, right? Why are you talking to me about, I mean, I get approached by people that want to sell me data science platforms. So I think, Jesus, I mean, come on, do a bit of research and realize maybe we shouldn't send that to Michael at night.
Yeah, sounds very cool. Yeah, actually, like there are already like a lot of companies that offering I think the name is the chief data officer in their companies. So they're like it's not just future, it's already right now. That's the trend, adopting the right data using for a company.
Yeah, absolutely.
Mm-hmm. Yeah. So here's a bit more a closer question to your field here. What would be like a release time for the next version of KNIME? So like, is there any like leads or improvements that you want to just share us right now, or do you want to just wait until it comes out?
No, I mean, we release twice a year, right? There's always the summer release, and then there's the Santa Claus release on December 6th. That just happened to turn into a bit of a tradition.
Mm-hmm.
Earlier this summer, we released a couple of cool new things. I mean, one is a Snowflake integration. We already had a Databricks integration, but now we have that for Snowflake as well. On the enterprise side, on the server side, we now have what we call data apps. So it allows you to have a KNIME workflow be deployed to the server, and there it instantly turns into either just a REST service, so it can be called by other applications, but you can now also embed these visual data apps, which is essentially like a web page. You can embed that into other applications or really run multi-step, very interactive analytics data science applications that are built purely based on a KNIME workflow. So
yeah, sounds pretty good. Yeah.
Big highlights. Yeah.
Your big highlights. Excited about the new functions. Look forward to the new release.
Yeah, and it's probably, I don't really know when this is going to be aired, but at the end of September, we have fall data talks coming up where we have a couple of customers talk about how they're using some of this functionality in real life. And we also have a presentation around moving KNIME execution to the edge. It's also a new feature that we just recently released.
Yeah, cool. So this is like a short-term goal for accomplishment for KNIME already. So like let's talk about like for a bit longer terms here. What would be your plan for like as the next steps, like for long term for KNIME's future? So for the past decade, you have built up a lot of great functions that to excite the data scientists. How about like for next decade? What's your grand design on the KNIME platform here? Anything you could share with us?
Ask an engineer to dream. I really think that a lot of our functionality that we currently sell to enterprises on-prem is going to move into the cloud. So it's going to be much more of an on-service offering. There's going to be much more of a marketplace around these types of functionalities, essentially connecting data scientists, experts to organizations that need data science and need certain specific type of vertical expertise. And for KNIME is a perfect vehicle to do that, right? Because it's very easy to use these visual workflows to also document what you're doing. So the risk of having a code base written by somebody else that nobody understands anymore is a lot smaller with visual workflows. So I think there's going to be much more of this the hub, or this marketplace will turn actually into much more of a meeting point, into a global meeting point for data science experts right? And people consuming that. And I think that will also allow us, very similar to programming languages, keep adding abstraction levels. I think we'll keep adding that. A little bit like we now, instead of having to train a decision tree and a few other classifiers and do your own selection, we now have an abstract component. We call it, this essentially wraps around an entire little sub-workflow that's encapsulating AutoML, right? It's training a couple of models, automatically picking the best one. You don't need to worry about that anymore. So I think we'll see data science going up a couple of layers of abstraction, solving more and more complex problems. And they're very exciting. And KNIME, to me, I mean, this is still the only true open source visual programming environment for data science. We see a lot of adoption at universities. So I'm expecting that KNIME workflow turns a bit into a lingua franca for data science.
Let's hope so. Yeah. Well, that almost kind of approaching to the end of our interview today. We have prepared a lot of questions, and you will answer to us to details very perfectly to your thoughts, your ideas, and your plans. So is there anything else that you also want to discuss that we haven't mentioned here that you still want to tell the audience about KNIME, about your other ideas, anything?
Yeah, I would like to talk a bit about this trend of considering low code or no code solution like something that's kind of for the dummies, and oppose that a little bit, because it's especially, I mean, there are visual no code, low code tools around that are specifically designed to solve simpler problems. But in the KNIME context, it's really, we should consider this as a still fairly complex tool. You can do very complex things with KNIME workflows. It's a low-code environment that allows you not to worry about the types of things that you shouldn't worry about as a data scientist. Maybe you want to, fine, then you can reach out to the code. But if you don't really want to know how your random forest was implemented, but you just want to use it, then being able to just grab that component, drag it over, and you have control of all of the parameters. So you still need to know what a random forest does, but you don't need to understand the specific implementation. So I would like to encourage people to see low code, no code, not always as a simple solution to solve easy problems, but really understand that the KNIME way of doing low code for data science it is visual programming. You are programming fairly complex data flow type setups, and you can do pretty complex stuff with those workflows, but you do them at the right level of abstraction.
Yeah, great. Sounds pretty cool about like the no code thing here. It would definitely like help in the our data science in understanding the stuff within the visualization inside. So that kind of reaches to the end of this interview here. I'm really happy to make this interview again. This is Vincent. Thank you, Mr. Michael. Thank you for making this interview work. And hope you have a nice meeting, a nice evening on your side. What time is it on your end there?
It's now 6:45, and thanks for the invitation, Vincent. It was a pleasure being here.
Thank you. So yeah, look forward to seeing you again. And thank you. Bye-bye.
Bye.